Good day, my audience. This is a lesson on systems of linear equation. That is what we're going to treat today. And previously, we've done lessons on matrices, determinants, how to use row reduction to get determinant, how to use row reduction to get the inverse of a matrix. Today, we are going to look at how to use row reduction to get to solve a system of a linear equation. That is in number 3. But before that, we're going to look at how to find the rank of a matrix, number 1. Then number 2, we're going to know how to reduce a matrix to a row canonical form. And then we'll now look at how to solve the matrix using the row canonical form. So I'm going to start with the first one. The first one is how to find the rank of a matrix. By the way, the rank of a matrix is the number of non-zero rows that remains when you reduce a matrix to echelon form. So that means we are going to reduce the two matrices matrix A and matrix B to row echelon form. That is reducing it to upper triangular matrix. That's what I mean. So the first one, A, is reducing the matrix A, which is 4 minus 2, 1, 7. We have 2, 1, minus 3, minus 8, 1, minus 3, 2, 3. We're going to reduce these to upper triangular form. We're reducing these to, I'm going to be watching my time, reducing it to upper triangular form. So, and to do that, we're going to have this. First of all, this is row 1, this is row 3, row 2, and that is row 1. Okay? So it is in the proper set, okay? It's not in the proper setting. I want to bring row 3 to the place of row 1 and take row 1 to the place of row 3. That is swapping rows. We have row 1, swap row 3, will yield this. 1 minus 3, 2, 3. 2, 1 minus 3 minus 8. And then bring this one down. 1 and 7. That is swapping row 3 and row 1. This will help us to eliminate this and this as zeros. Okay, so we're going to have row 2 is equal to row 2 minus 2 row 1. And also we're going to have row 3 is equal to row 3 minus 4 row 1. Using row 1 to do these things, this will yield out, I'm going to do the operation there quickly. The operation, let's quickly represent row 2 here. For row 2, okay, let's write down row 1 first. And then for row 2, we have 2, 1 minus 3 minus 8. And then 2 row 1 is 2 times 1. 2 times is minus 6. 2 here is 4. 2 here is 6. So we are subtracting these two. When we subtract, we write in directly. This minus this is 0. 1 minus minus 6 is 7. Minus 3 minus 4 is minus 7. Minus 8 minus 6 is minus 14. Okay? Then let's take care of this one. Row 3 is 4 minus 2, 1, 7. And then 4 row 1 is 4 here, minus 12 here, 8 here, and 12 here. So when we subtract this, we are writing down directly 0. Minus 2 minus minus 12 is 10. Okay? 1 minus 8 is minus 7. 7 minus, this is minus 5. So this is what we have as the new matrix. Now we have succeeded in turning here and here to be 0. Next is to, now we have the leading variables. The quotient of leading variables here 1, here 7. We need to get one leading variable here. And that means we just need to eliminate this, okay, and turn it to 0. Before we do that, I see that here is 7, minus 7, and 14. So we can divide here by 7 throughout. If you have row 2 divided by 7, will give us this. 1 minus 3, 2, 3, 0. Here divided by 7 is 1. Here divided by 7 is minus 1. Here is minus 2. Okay, so we have 0, 10, minus 7, minus 5. Now next, I'm going to eliminate this. Since here is now 1, I can eliminate here and make it 0. Okay, to do that, we're going to have row 3 is equal to row 3 minus 10 row 2. Row 3 minus 10 row 2 will give us, okay, let's do the operation up there. Row 3 is 0, 10 minus 7 minus 5. And then 10 row 2 is 0, 10 minus 10, 10 row 2 minus 10 and minus 20. All right, so we subtract this. Let's subtract this. 10 minus 10. Okay, let's write in 1 minus 3 first, then 2 and 3. Then here we have 0, 1, minus 1, and minus 2. Then here, when we subtract this, we have 0. Subtract this, you have 0. Subtract this, you're going to have 3. Subtract this, you're going to have 15. Okay, so you can see that we have the pivots. Let's call them pivots. We have the pivots here, 1, here is 1, and here is what? 3. So at this point, since we have 3 pivots in these 3 rows, we don't have a row that is not 0. Therefore, we can say that the rank of A is equals to how many pivots? 1, 2, 3. Of course, that is the number of rows that is not 0. So that is equals to 3. So the number of rows that is not 0, the number of non-zero rows is 3. The number of pivots is what? 3. Therefore, the rank of A is equals to what? 3.